Hey guys, today we're going to solve a first-order linear differential equation using an integrating factor. If you want to see how the formula was derived, check out part 1 in the description box below. The first step is to identify p of t. The second step is to find the integrating factor I of t. The integrating factor is sometimes called mu instead of I of t. It's just a variable. Step 3 is to find y of t. You can do this by using either method 1 or 2. Just use whichever method you're more comfortable with. Some of you may be thinking, wait, in our problem there's a t in front of the y prime, so it doesn't match the general form of a first-order linear differential equation. But we can get rid of this coefficient with some basic algebra. If we divide the entire equation by t, y prime will have a coefficient of 1. So p of t is equal to 3 over t. Now let's find the integrating factor I of t. The formula for I of t is e raised to the integral of p of t dt. So now all we have to do is substitute 3 over t for p of t, which we found in step 1. The integral of 3 over t is 3 ln t. Using the properties of ln, we can change 3 ln t into ln of t cubed. Now the e and the ln will cancel, and we're left with t cubed. So I of t is equal to t cubed. It's finally time to find y of t. Let's do method 1 first. In method 1, we multiply both sides of the equation by the integrating factor. We then undo the product rule on the left side of the equation. The right side stays exactly the same. We integrate both sides. On the right side, there's a constant called c. If we had an initial condition, we could have found the value of c, but the question is asking for just a general solution. To isolate y, we divide the equation by t cubed. We're left with 1/5 t to the 5th plus c over t cubed. Now let's do method 2. If you're the type of person who can easily memorize formulas, you'll probably use this method on the exam. I personally memorized it and just remembered it by Iggy, because it's ig over I. I don't know, it helped. Anyways, we just substitute I of t and g of t into the formula and simplify. G of t is t and not t squared because in step 1, we divided the whole equation by that coefficient in front of y prime. So t squared divided by t is t. The integral of t to the 4th is 1/5 t to the 5th plus a constant c. We keep the denominator the same. And then we divide each term by t to the 3rd. We get the exact same answer as we did for method 1, 1/5 t squared plus c over t cubed.